So take a look at the front side of this worksheet. During the spring runoff, the level of lake rises. Apparently, I never passed English in high school. If the level of the water grows according to a specific pattern, answer each question below. So we have a lake, has some amount of water in it, and it's going up. The level of the lake is going up, and we don't know in what fashion it's going up. Let's say we took a measurement every day. How many measurements would it take to know if it was a linear equation, if it was linear growth? Okay, it's 2, 3, 4. Let's look at a couple things. If I had a chart of x's and y's, and I had, like, I don't know, the first 4 days. So I measure the level of the lake, and let's say it's 16 feet. Is that growing linearly? Oh, it hasn't grown at all yet, right? So we look at it the next day, 19 feet. How is the lake growing? Well, I don't know. I could say that 16 plus 3 is 19, but I could also say that 19 divided by 16 is 18% growth, almost 19% growth. So is it growing linearly or is it growing exponentially? I need another point. So I measure the next day, and it ends up being 22. So that would be linear because it's growing 3 feet every day. So why did we need 3 pieces of information? And we used those to find the growth, but how come 2 wasn't enough? Why do we have to have 3? What could change? The what? The increase amount? So the explanation is I need 2 second differences, or 2 first differences. So to know that it's linear, you need 3 points. The reason is you have to calculate at least 2 first differences. Now, having said that, there are complicated equations that would look linear for a while and then they would change. In fact, you could make one that was so complicated that the first 100 terms are linear and then it's not linear after that. It'd be kind of a mess and we wouldn't want to do it. But as far as we're concerned, it's either linear, quadratic, exponential, or neither. So in this case, 3 terms is enough and we call it good. All right? So let's look at exponential. Well, let's go back actually. So let's say there were 10 feet of water in the lake, and at the end of the first day there were 15. Is that enough to tell if it's exponential? No. What do I need? I need at least 1 more point. Let's see what that does. So let's say it's 22. How do I test to see if this is exponential? So divide 15 by 10. Oops. 15 divided by 10. 1.5. How fast is it growing? 50%. 22 divided by 15. 1.46. Is that close enough? No, that's not quite close enough. If it was like 1.4999, then we could call it good. So, well, we don't know. It's not linear and it's not exponential. But it could be a lot of other things. So just because it's not those 2 does not mean it's quadratic. Okay, so we need 3 points for exponential. And the reason is we need to calculate that common ratio twice. All right, quadratic. Suppose we started with 10. Oh, that was weird. So we have 10. Second day, let's say we have 12. And then that's obviously not enough. So the next day we'll have 14. Is that enough to tell that it's quadratic? Well, let's look. So plus 2, oh shoot. let's make that a 15. I'm sorry. 15. Plus 2 plus 3. How do we know if it's quadratic? Second difference, so I have a plus 1. Oh, great. The second difference is 1. I need another term so I can create another first difference so I can create another second difference. So if this was 19, then that would create a first difference of 4, which creates a second difference of 1, and those, man, that was interesting. And these match, so yes, it's quadratic. So I need 4 points, because in order to calculate 2 second differences, you need 4 points to do so. Okay? All right, let's change gears just a little bit. So now let's suppose I know it's linear. If we have a lake and I tell you it's linear and I ask you to find the equation, how many days do you need to measure the lake in order to write the equation? If you know it's linear, I tell you beforehand it grows linearly, how many points do you need just to write the equation? Well, let's look. Is that enough to draw a line? How many lines are there that go through that point? Lots, an infinite number. And we know it's going up, but it could be this line or that line or that line, lots of them. So in order to figure out exactly what line, I need one more point. So 2 points is enough. Let's look at the chart. If I knew that on day 3 there were 18 feet of water, how come one more number would be enough? What do we need to know in order to write the equation? What does that missing piece of information tell us about the lake? Per day. It's the growth per day. So if I said that this was a 20, how fast is it growing? 2 feet per day. And then I could backtrack to day 0, and then I would have the growth and the original amount, and that would allow me to write the equation. What if instead of 4, it was 6? Would that still be enough? Could I get the growth per day if I skipped a value? Well, I grew 2 feet, but how long did it take me to do it? 3 days. So 2 feet divided by 3 days is 0.66, which is like, what, 8 inches? So it grew 8 inches per day, and then we could backtrack back to the beginning and write the equation. So for a linear equation, you only need 2 points. Okay? And it's significant that you need 3 points to figure out what type of equation it is, but you only need 2 points to write the equation. It always takes one more number to figure out what the equation, to figure out what type the equation is, than it does to actually write the equation. That's always the case. So for exponential, if I knew 1 point, that wouldn't be enough. But if I knew another point, that guarantees a single line. For instance, if this was 1, 1, 6, and 2, 12, how many ways are there to get from 6 to 12 in 1 year? Exponentially. What's the growth rate? Timesing by 2. If you times by 2, you'll jump from 6 to 12. If you times by 2.1, you'll land a little bit too high. And if you times by 1.9, you'll land a little bit low. The only way to do it is by multiplying by 2. So you need 2 points because it takes 2 numbers to find that common ratio. All right, quadratic. So if I have 1 point, that's obviously not enough. If I have 2 points, how many parabolas are there that go through those 2 points? Well, I could do a parabola that looks like this. I could do a parabola that looks like that. I could do one that looks like this. They're an infinite number. So in order to figure out exactly which parabola it is, you need a third point. The reason being, in a quadratic table, you need to know the second difference in order to figure out what the equation is. And it takes 3 numbers to create a second difference. 2 numbers will make a first difference, but you need a third number to create that second difference. All right. Let's actually do one of these. If we have a bank account that 10 years from now we'll have $1,500 and 16 years from now we'll have $1,850, use a calculator to create each explicit equation below and answer all the questions. So for this first one, it's linear. And we're going to use the same information to create an exponential and a quadratic in a minute. So I know 2 points. I know 2 x's and y's. I know 10, 15. They also gave me 16, 1850. Now in the past we've used this to create equations. You could find the growth per year and then you could backtrack to year 0 and figure out the y-intercept and write the equation. Never again will we do that. That takes way too long. We're going to plug it in the calculator and ask the calculator what the equation is. Okay? Pull out your calculators. Does anybody have one that's not an 83 or an 84? You are out of luck. I don't have any idea how that works. Anybody else? You have an 86? Okay, you're going to use X stat and Y stat. I'll come help you in a minute. Okay. Good luck, Bo. I have no clue how that thing works. All right, so everybody push the stat button. It's right underneath the delete key. Now you see edit, calc, and tests. Tests is for a statistics class. We'll never use it. But edit is where you enter information, and calculate is where you create equations. So we're going to go into edit and hit enter. Now I have information in there. You may or may not. It doesn't matter. Never push delete to get rid of numbers. If you accidentally push delete on one of the lists, it will disappear. And then we have to do something to bring it back. So does everybody have list 1 and list 2? So you have an L1 column and an L2 column. So go to the top of the list, and instead of pushing delete, throw it away and move everything over. Press clear and then hit enter, and all the entries should disappear. We do that for list 1. We'll be wrong. expressions, you have oh, or whatever. 915 is the initial amount. Well, here are a bunch of until I get to